Okay, let's talk about compound interest. We have a formula that looks like this. A equals P times the quantity, 1 plus R over N to the NT. We have a bunch of different variables, so we need to figure out what each of them means. The A at the beginning is the ending amount, and that's the amount that you have after your interest has been earned. The P is your starting principal. That's the amount that you deposit into an account. The R is the rate, and you have to use that as a decimal. So if it's given to you as a percent, you have to divide by 100 to convert it into a decimal. The N is the number of compoundings per year, and we'll talk about that just a little bit more here in a second. And the T is the time that you're depositing your money for in years. Okay, so that N, the number of compoundings. You might have in your words about a problem, it might say annual. If it says annual, that means N equals 1. You might see semi-annual. And so we're wondering if something is happening semi-annually, how often does it happen in a year? And that's 2 times a year. Don't confuse that with biannual, which means every 2 years. Then we have quarterly. And you can ask how many quarters are in a year, and that would be 4 quarters, so N would be 4. And then you might have monthly. Monthly, and how many months are in a year? That will be 12. And you might have weekly. This is a little less usual, but weekly, there are 52 weeks in a year, so that would be 52. And then another one that you might use for calculations, but we don't see often in the real world, that would be daily. And for that one, the N equals 365, and we'll use that value regardless of if the year is a leap year or not. So 365 days in a year. So if we have a formula with the values already plugged in, we want to see how we could calculate this and find out how much money we're going to have in our account at the end of the time. And I can see a few things about this formula. The first one is that the 1,000 is in there where the P was. So the 1,000 means the principal is $1,000, what I'm starting with. And this is my interest rate. So it's shown as a decimal, 0.025. That means it's actually 2.5% interest. And then the next thing I can see is my N is a 12, and if I look back at that table, you can see that N equals 12 means monthly compounding, and then the 7, that's the number of years, so 7 years. There's my rate, and there's my principal. Okay, so we'd like you to go ahead and take a look at this formula and see. Think about the order of operations. I'll go over that real quick. So we have PEMDAS, or please excuse my dear Aunt Sally, and the P stands for parentheses. You handle anything inside parentheses first. The E stands for exponents. And we have exponents here. That's our 12 times 7 up there. The M and the D we handle together, so we do multiply or divide. whichever comes first as you go left to right. Remember that? We did this before. And then the add and subtract. And that's the same thing. You go left to right. If you see subtraction as you go left to right before you see addition, you have to do it first before you do the addition. Okay, so let's rewrite this showing all of our operations. So we have A equals 1,000. Remember, 1,000 is smashed up next to the parentheses, so that means it's actually a multiply. So we have 1,000 times this quantity, and inside the parentheses I have 1, that's showing plus, and then it's 0.025 divided by 12. So that divide there was written as a fraction. I can write it out with a division symbol. And then my exponent, it's to the power of 12 times 7. Okay, when I'm actually working this problem, I want to put numbers by all the operations so that you can see what you do first and what you do second. So the very first thing I'm thinking about is working inside the parentheses. So I want to work in here. And the first operation I should do in there, I have addition and division. Division comes before addition. So that's going to be my first operation. And my second one will be that addition. And then I'll have taken care of all of the values inside the parentheses. So the next thing I'll want to do is the exponent. I need to calculate that exponent 12 times 7. I can go ahead and do that as step 1 as well, so that I have that multiplication taken care of, and then I'll handle raising to that whole power as my third operation. And then after I handle that exponent, then I'm looking for multiply, divide, add, subtract. And so my last operation on the right hand side is going to be to multiply. So there's the order of what I need to handle, how I need to handle those operations. Let's go down and see how that actually looks then. So on my calculator, I need to, first thing I have to do is this 0.025 divided by 12. So 0.025 on my calculator divided by 12. And I push equals. I want to keep this long value here, this 0.0020833 repeating. I want to leave it on my calculator, and that's very important for the compound interest calculations, because if I write down what I have from the calculator is actually storing more digits than it's showing, and I'll lose those if I just go off of what's written on the calculator. So I want to make, and I don't want to round for sure, because then I'll even lose more precision that way. So I'm going to leave all those digits. The next thing I need to do is right here, this addition, that's number 2. So I can write down some things just so that we can kind of track what I've done so far. So let's do that. A equals 1,000 times, I have 1 plus, and I've calculated this, it's 0.002083 repeating. So I'm just going to write it like that. And then I also said we should do that 12 times the 7. So if you know that in your head or you can calculate it by hand, that's fine. Otherwise, you can do 12 times 7 on your calculator and write down that 84. And now I'm going to go back and redo where I have this division here. So 0.025 divided by 12 equals, and I get that same number that I had before. Now I'm going to go on to this addition here. So I have 1 plus the 0.025. And I can do, I have the 0.00208 on my calculator, so I just say plus 1 equals, and then I have still 1,000 times, now inside the parentheses I have 1.00208, 3 repeating, raised to the 84th. So I've done number 1 and I've done number 2. Now I'm ready to do number 3, which, if you remember, that was our exponent. So we're going to handle the exponent next. So to the 84th. To do that on my calculator, I have this key here that is y to the x. That's the key I have for my exponent. You might have one that's a little bit different. You might have a caret That key is also for the power, so you would use that instead of the y to the x. It works the same. You might also have x to the y. I've seen that on some calculators. So you're finding the one that gives you that exponent. So I'm going to leave the 1.00283 repeating, sitting on my calculator, and then do to the. So that's what I'm pushing this key for, to the. And I want it to go to the 84th power here. So I'll type in 84 and push equals. So now I've handled this part right here. So I have 1,000 times the quantity 1.191029, and it's going on and on. So I'm just going to write down a little bit of it and put dot, dot, dot. I'm leaving it on my calculator though. I'm not going to get rid of it from there. Now my last operation was number 4 up here, was to multiply by 100. So I'll do that next, or by 1,000, sorry. So then we'll say times 1,000 equals, and then that, remember, is my A, so I have A equals 1191.029, and there are further digits, but this is money, and I do want to round to the nearest cent. So I'm looking at the nearest cent, and I'm looking at the digit after. It's 5 or greater, so I need to make my answer $1,191.03. Now, if you're not getting the exact answer I am, you're probably dropping some numbers off as you go on your decimals, the decimal values. So don't round at all so that you can get this exact answer for this problem. Okay, so here you might have written a little bit about your calculator and how you can find the exponent, and that will be about it for this page.